Welcome to episode 7. Vertex array object. Lovely. My name's Blades and I don't know why. People think that the vertex array object is a hard thing or a difficult thing to comprehend because it's a menu. It's a menu of buffers. And that's all it is, just like the page I'm looking at in front of me here is a menu of code lines. And you just go down the code and it produces a program. Oh, and it also says fix this here. Yeah. Okay. Who spotted it? Who spotted it? Come on, put your hands up. I only did half the code. Yeah, well, there is that. So if I put a comma and just one of them, there you go. It fixes the code. I know. I'm a bit slow at times. Yeah. And I think that means I didn't do this either. Did I? Yeah, okay. I didn't do this. There you go. Is that now true? Is quad, has textures, has normals, yeah. That's a bit better. That might actually work better. Any more fixes? Yeah, there will be. But not in here, I don't think. I didn't do too badly. Watched the last episode and yeah, it looks actually quite good. It's starting to come together quite nicely. I'll save that out and get rid of it. I'm not interested in that yet. GFX, here we go. Model. VAO. That's what we're doing. Yes. Let's make a VAO. So, how do we do that? We'll need something. Well, go on. I'll put M_VAO. Q vertex array object. Is there such a thing? That's a very good question. There is. There is an actual thing. It is a thing in Qt. So, hash include. And it's going to be Q open GL vertex. There it is. Vertex array object. Now, how do I get that thing not to work? Yeah, escape. Okay. Thank you. I just want you to leave me code alone, please, Visual Studio. I've had enough of those kind of silly things going on. Capital GL, please. Yes, good point. Thank you. I'm glad I leave myself notes. Yeah, bad spelling as well. So, we'll put the E in here. There we go. That's my spelling updated. At least you can tell that I watch my own stuff. So this is going to be a new one, isn't it? Vertex array object. Yeah. It is. Yeah, that's okay. So it's a Q open GL vertex array object. That's going to be star. And it equals a new one. Thank you. Don't know what I did there. Q open. Press the wrong button, obviously. Open GL vertex array object. There we go. I'll put those on because I can. I don't want it to hang on to anything or be anything different, so yeah. Are we okay with that? I think we are. Let's have a look at my notes. Yeah. So that equals a new one. Right, okay. So, M underscore VAO. Create, please. Create. Yeah, it puts it into an arrow for me because it's a pointer. Remember, pointers are just memory addresses somewhere floating around out there. And I haven't done any deletes either, so be aware that I haven't deleted anything. It's just one of those things, because this is just getting the stuff together. We're not doing anything special in these. We're just getting the code together. VAO, we need to bind it, otherwise it won't record what we do. There we go. Right, that will now record what we do. Anything that comes after that in this file, well, in this create VAO, will be added to the menu. That's just our menu title. Our menu title is M underscore VAO. That's all it is. And let's see what we need to do. We want Vertex buffer objects now. We want VBOs. And I bet those are a thing as well, aren't they? Let's have a look. Hash include. And it's Q open GL in capitals. And then it's Vertex. No, it's only got Vertex array up. Hold on a minute. Hold on a minute. How are you doing it then? It's just buffer. Okay. They don't put the full thing in. Okay. Yeah, buffer. That'll do. We'll have an OpenGL buffer, we'll call it. This is going to be our VBO, or Vertex Buffer Object, should I say. So what I'm going to do is call this one position, M underscore position. And it's a Vertex Buffer Object, isn't it? So it's a Q open GL buffer. There we go. Position. Not going to do any stars. And all we're going to do for these, I believe, is just create them and fill them. Fill them full of rubbish. Knowing me. So, Vertex Buffer Object, yeah. And that's just going to be Q OpenGL buffer, yeah. Okay, I like that. I'm thinking that I do want to make it. Oh, yeah, we do, because we need 3 of these. Yeah, so we need new ones each time. That's going to be a better way of doing it. I'm going to do it with new. Yeah. Sorry. It's a life choice. Where do you put your information? Well, we don't want it too close. We don't need it on the stack, as it were, which is the chip memory. I'll just send it somewhere, anywhere. Equals new Q open GL buffer. Again, just do that. Don't want anything in there. Don't want to tell it anything. No real point in doing that kind of thing. So let's do as before. M underscore position. And that's just going to be create. It's a good start. We've now got it. We've now got our position buffer. Now, this position buffer is going to be on the graphics card, just like the vertex array object is going to be on the graphics card. How does that work? It just has. It's just happened. You didn't even see it happen. Did you blink? No, you didn't blink. Good. Right, it happened. So, the color buffer, what we're going to do now is we're going to bind it. Sorry, the position buffer, what am I talking about? Yeah, I don't know. Underscore position. I bet you're glad I know what I'm doing. Oh dear. Bind it, please. Come on, Blades. Bind it. Right, so we've got our position buffer. We've created it. It's now active, which means we can now manipulate the active buffer, GL buffer. And this will make sure that our VAO records everything. So it's recorded that we've created and bound it, so it now knows that it exists. So it's going to put a reference on the graphics card for that, which is very nice of it. Now, what we need to do is allocate the information. We've been very good. We've got it out of the file. We've sucked it all up into loads and loads of structs. And here, what we need to do, or now you know, now you're going to see why we need an API, because this next line. This next line is m underscore position dot allocate open. Now we get two options, as you can see from it says one of two, void allocate int count. Now if I use that option, all it'll do is give me an empty buffer of a size int. I don't want that. What's the second one? Second option is void allocate constant void star data. Okay. Now we've got all of our stuff in structs. And then it wants an int count. It needs the size. So what it's going to be looking for in this case is positions and then size of. Is it size of? It's all lowercase, isn't it? Yeah. Size of, because that's a keyword. That's wow, we've used a C++ keyword. Size of. Ah, dear me, position. There we go. Now, that gives us errors. Now, that needs to be a star. In other words, a reference. It needs the address. So it's going to allocate that amount of space, and then it's going to pour in the data from that address. Literally pour it in like a jug of data, pouring into that buffer. And that buffer is on the graphics card. And that's why it's such a weird spelling. It's an allocate rather than anything else, but it's doing quite a lot behind the scenes, is Qt, to get all of that done. That allocate, oh, it saves you such a headache. So let's make a, I'm going to now reword that. I'm going to call it dummy. And then a position, Shift P. Because this is going to be altered. We haven't got it. We haven't got an API. But what I can do to stop the errors is I can create one. and it would be something along the lines of float, dummy position, open brackets, close brackets, equals, open curly brackets, 0.0f, semicolon. There you go. Everything works. So it's that dummy position that we've got to replace. So, need to replace with with data from API. And that's why we need an API, because we don't have it in that format. We also don't have one of the most important things, which is something called an index. We haven't got index at all. We might have specific indexes to specific things, like on the faces we have the vertex index, texture index, and the normals index, but we don't have the overall index. We don't even know how many we've got. We don't even know the size of, which we need to pass through really as well. So we're going to need those. Well, actually no, it'll do it itself. So we need to pass through the actual positions. The size of will take care of it, and we need an index of some kind, a count, an index. So let's carry on. Let's carry on with our dummy code, because that's what this is. This is me just putting together the actual code rather than programming it. Just shifting this around and doing the other stuff will fix it all up later. So now we've got our positions. What do we need next? Well, we need the whole thing again. So we need to do the whole thing again, but instead of position, it's going to be m_color. We haven't got color, so we have up there, and we have m_position up there. We can't call it that. Let's put position buffer, because that's what it is. It's a buffer. Color buffer. Okay. Can't duplicate m's, because we're going to an m_ is what I call a member variable for a class. As we haven't got a class going at the moment, they're just they're just locals, but they will become member variables in some way or another. So we can do that one, that one. That's alright. Color buffer, copy. But you can see how you've got to be careful now with your naming of variables. You've got to be very careful not to clash. I just remembered to look up and then saw these two here. So we've got to make sure we don't clash with all this lot up here, which would be a bit of a oops if we did. There we go. We've got our position buffer, we've got our color buffer. Now we do need an index of some kind. So we're also going to have, this is silly but it's true, copy. And paste. We're going to have an index buffer as well. So we need three things. What does the index buffer do? Well, it works for us in the way that the faces worked for the OBJ file. Have a look at the OBJ file here. You see how the faces are all split up like this here? that means vertex 1 has normal 1, vertex 2 has normal 1, vertex 3 has normal 1. So that vertex has that normal, that vertex on that line has that normal. And it's not until you get to vertex 5, 0, oh, just call it 5. Sorry, 1, 2, 3, 4, 5, yeah. 1, 2, 3, 4, 5. Not until you get to that vertex there do you get normal 2. Cheers. That one. So you can see how it's gone through it all. So if you have a look at that, it's always 1, 1, 1, 1. That's a quad. 2, 2, 2, 2. 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6. That's actually 6 faces. So you could use the normals as the number of faces. That's interesting, isn't it? So for each face, we could just take the index of that, and that will give us our indexing. Before dubris. Thinking. Thinking gets us everywhere. So, copy. Paste. Let's fix this up first. There we go. So, we've got our 3 buffers, and we are going to need an index somehow. I mean, we haven't even got that yet. The API will provide that index. That's one of its. That's what it generates. That's the main thing it generates. And that's what we really want. So once we've done that, well, we can just release everything. We don't need to keep anything more in our local memory. So at this stage, we can get rid of it. We don't need it anymore. So that means we can get onto the next object, load that up, and put another object onto the graphics card. Yeah, a plan is starting to come together. But we must release them in the correct order. First thing that we need to release is the VAO. Because if we don't, the VAO will record that we are releasing the buffers, and we don't want the VAO to record that. If it does, it could, not work. Yeah, because it will be taking notes that we've created all of these buffers, and then it'll be deleting those notes because we're releasing all of these buffers. That would be classic, wouldn't it? So it's just release. Didn't arrow. No idea why not, so we'll put that in for it. It's having a bad day. Why can't you release? Oh yes, you can. Now, when you are doing something like this, you should always do it in reverse order. That is the programmer's guide. In this case, it doesn't actually matter. But I'm going to stick with the programmer's guide. So it's m_index buffer. The reason it's a programmer's guide is because if, for instance, index buffer had a dependency that the color buffer, it requires something from the color buffer to work, and we forget that at some stage, or we don't delete the index buffer, and we delete the color buffer first and then go on to use the index buffer, then it wouldn't work because it has a dependency. So to get around dependencies, always do things in the, as you create things, always delete them or release them, in this case, in reverse order. Where's release? There it is. There we go. So color buffer is next. It also means that I don't miss them usually. down. Release, please. Please release me. Let me go. Position. Is that spelled right? Yeah, I think it is. I'll check later. Release. There we go. And that's it. That's your VAO. That's all the code you need to create the VAO which we are going to be using for our test. So we now have all of the code. Create shader. You bind it. I'm not sure that we need it currently bound at this point. But it doesn't matter. Does it? I'll think of it. It depends how we finally code this later. But if you rebind it, it doesn't cause an error. No, it doesn't. That's okay. Just ignores a request. That's fine. But I'm not happy with that bit still being awake at this point. So it's a bind, it's going to be a release. I'm going to pop it in here. So it's in program. Dot, and I bet there's a release for this, isn't there? Yeah, there is. I thought so. Keep things tidy. There we go. So I'm happy now that we've got enough information in gfx.h for us to be able to run those two functions, and obviously if we put them into a class, like a creation class or something. I'm not sure how we're going to classify these yet. So we'll just do one more of these. And we'll call it a renderer. We'll have a renderer. I wouldn't say that's graphics card stuff. But it is the OpenGL stuff, so I'm going to put it in here anyway. I may as well do it now, there's not really much to it. So it's void. What should we call it? I'm just going to call it draw object for now, because I don't know what to call it. I haven't got a name for this, so there we go. And how we're going to do that is we would need we'd need a Q matrix, wouldn't we? So put that there. What do we have here? This was all the buffers, wasn't it? And this is what you are allowed to do, by the way. Because it's only bits and bobs, I always put the includes with them. Hash include. This is definitely going to need some kind of Q matrix thingy. Yeah. And I'll have 4x4. Yeah, thanks. That'll do. Because I need a few matrices in this. View matrix, and it's going to be all the way down here, isn't it? Yeah, 4x4. We would have a model. Yeah, that's okay. Well, it's a dummy model in this, actually, yeah. So, dummy, so you know that it needs to come from outside dummy model. It's not part of the function. Copy that. Control V, and we will have view, and we will have projection. There we go. That's that. We will need another. And this one is going to be full matrix. Dummy full. Oh, actually, no. Dummy MVP. We can call it, can't we? Yeah. Why not? I don't know. Next, we would do the shader. So, program. We already know what mprogram is. Get off there a minute. Mprogram is part of that. There we go. Copy. So, this is going to be a dummy program, because we just don't have the stuff for it at the moment. Oh no. No. Don't like this. I'm going to put current shader. Yeah, because that's how it sounds. Because there's going to be more than one shader. So when you're drawing the object, you need to know which shader you're using. So we've only got one at the moment, because that's all what we're going to use for testing. This is going to have multiple shaders. It's going to have texture shaders, color shaders. That's your first two. And after that, you may have underwater shaders. You may have the map shaders for the actual how the map looks. Weather shaders, rain shader. That would be a lovely one to do. I'd like to write that one. Anyway, what else would we need? We would need the VAO. Really? Yeah, really. So we'd need the VAO. So that's that one. So you'd have your current shader paired up with your current VAO. Yeah. So you'd pair up your shader and your VAO, because they are held separately, because as you can see, it's separate. The two totally separate functions. And we would do something like bind on them. Again, we'd do something like bind on them. So we'd bind those two. It's going to give us red squigglies. Can't do anything about... Oh, that's because I've put that in. Sorry. So they are stars. It's not going to work, that, is it? It's not going to pass the tests. It's not going to let me do that, is it? Oh, well, who cares? Tough. You'll have to stay as an error. There's no... I'm trying not to make red squigglies, as you... Pretty obvious, really. Once we've got those done, all we need to do is set that... Well, as I mentioned or alluded to before... That's a nice name. Alluded. alluded to, we need an MVP, which is why I've got this. So how are we going to do that? We would take the dummy MVP here. Our dummy MVP, that is equal to, let's see, got to get it the right way round. So it's projection view model. Yeah, I know. I'm going to have to check this, but I'm hoping that I'm getting this right. And it's asterisk times it by dummy view. There it is. Times dummy model. I will have to check that. With matrices, order matters. The order in which you multiply them makes such a big difference. You get it wrong, it's going to make a complete and utter mess of everything. I can't remember whether models first or projections first off the top of my head. Let's have a quick look on here. So, open GL MVP matrix. Gem lookout, location, matrix, uniform. Where you're multiplying them. Well, I've just walked straight past it, have I? God, this is an awful way of doing things. Projection view model. Projection view model. God, got it right first time. Yay! I'm the champ. I am the champ. But I do want to make sure everything is correct for you. I'm not here to make mistakes. So now we have to ask OpenGL to perform a command, which it's not going to do for us here because I don't... Oh, we have. Draw. We have got it. I don't believe this. Oh, wow. I love Qt. GL draw elements, and we are going to need two choices here, aren't we? I'm going to put this at the top actually. A bool, and it's going to be dummy is quad. Because now you're going to find out why on earth were we doing that. Well, we were doing has textures and has normals for when we are creating the VAO and the shader. We have to know if there are normals. For the normals shader, we're going to have a shader for each one. So if it has normals, we need to create a normal shader. If it has textures, we need to create a textures shader. If it has both, we have to create a normals textures shader that does both. Or can we just do it in one shader and let the shader decide what it's got? there's a thought. We can't do this without a true or a false, so we'll just put an equals false in there for now. Bool dummy is quad equals false. What? Okay. I'll leave you alone. I really, really don't care. Bind them. Bind that. I'm just getting rid of the red squigglies. Sorry, I can't do code with red squigglies on it. It will just completely naff me up. So home, if open brackets is quad, then GL draw elements, and that now becomes GL underscore quad. Quads. That one. Comma. And then we need the number, the count. So GL size I count. So that will be the number of index elements. So that is your index total. Num of size of. Will size of give me the index? Number of index elements, which is why it's called GL draw elements. And that is an int. So it's int. It's a dummy, because we haven't got the information. There we go. That. Okay. So if it's a... yeah, right, okay. Doesn't matter. There we go. That explains what that is. GL enum type. They will be GL unsigned int. Remember that, because if you don't give it the correct type, it won't throw a total wobbler, but that's what it's going to be expecting. You can get away, I suppose, with the GL int, but I wouldn't. I'd use, because you can't have negative indexes. That's the point of that. It's to stop you having negative indexes or any cock-ups. The last, because we're using an index, we can really just ignore that last thing. It says const GL void star indices. What it's asking for there is a pointer to where you want to start in the buffer of indexes that you have. Well, we want it to start at the beginning. So I'm just going to stick in a null pointer, and that will set it. That will just set it to the start automatically. And that's you draw elements for is quad. And yeah. Get rid of you. There we go. Right, so no red squigglies. Okay. And the next line is else. And it's exactly the same line except for one thing. GL quads becomes GL underscore triangles. I'll have that one, please. There we go. And now you've drawn it. That goes into the back buffer of your TV screen, your monitor or whatever. Goes into the back buffer for that. The actual buffer that you are seeing is not touched. It will become the back, when you swap over, it becomes the back buffer, the one you're seeing. So that's how they usually work. At the end of that, all we do is release anything that we've bound. So that's those, no, do it one at a time. Reasons, because we want to reverse them. I always do it in reverse. There we go. And that will become release meh, which we obviously can't put in yet. That's the code. That's your bonus code for today, I think, because it is a Thursday and I don't do Fridays. I do streaming on Fridays, so this is just a bit of bonus code, I suppose. That's it. That's all you need. That's how you draw an object. I know I've put a lot of dummy code in, but that is pure dummy code, because I've gone so far ahead that that isn't even part of GFX card. This is part of something completely different, and it's part of your render engine. This is actually what your rendering engine's all about. So that will get moved at some time. But there's 3 sets of code that we are going to be using later on when we structure our main here. Because our main has this test thing in, doesn't it? Can we get rid of that now? Yeah, we can. That's just no good to us, because we haven't even got a window to display in yet. Oh, that could be the next thing we do. As we move towards the API, or shall we do some of the API first? I think we have to look at that API. Some people think it's not straightforward, but it really is. It's literally just a for next loop. The API is so easy, it's untrue. And then all we do is pass the values through to the graphics card. So the next part of this is going to be source, add folder, and I'm going to call it API, as I always do, because I can't really think of anything else to call it. No, I shouldn't say that. So the API is going to send data. Let's have a look what we're going to call the file for now. Can I just get in here a minute? Control S. So main's okay. I've taken away all that rubbish. Do we still need this rubbish? Yeah, because we haven't really finished it all, have we? So I'll keep that around. I'm still working on that. Yeah, okay. Because that's the one I've never done before. Never literally done it this way. So this is completely new to me. Don't worry. I'm trying a different approach to it. It's not an experiment. This is the real approach to it. The finals. So API. I'll think of a name for it for the next episode. So I'll catch you on Monday with that. In the meantime, there will be some streams over the weekend for me relaxing. Oh yeah. And possibly kicking somebody's butt again, which is quite funny if I do, because I'm so bad at the games, it's untrue. Hoping that on Saturday I'll have Shooting Stars, which is the XCOM 2 Long War modification I'm running. Hope to see you there. Tomorrow I'm definitely going to be winding down with Guild Wars 2. Doesn't matter which extension. I don't care. I think I'm on Path of Fire, but who cares? I bought them. I'm sad. Take care, everybody. And Bayek, are we going to have some fun?